The vocabulary domain and range are words that you will be using throughout your upper level math classes. The domain is the set of all of the x values. In other words, the set of all of the independent variables. The range is the set of all of the y values, the set of all dependent variables. If you look at this really small little line right here, when we list the domain and range, we list the values in order from least to greatest, and we do not repeat values. So in this first representation, this list of ordered pairs, this set of ordered pairs, the domain is just the list of all possible values that x can take on, and we need to list those from least to greatest, and we need to put them in our curly brackets in our set notation. That indicates that we're giving the set of all possible x values, so the list. And again, least to greatest, so -3 is the least. Next is 0, and here's where that second part of this comes in. We don't repeat the values, so we don't indicate that there are two different ordered pairs that have an x value of 0. We just say 0 is a possible x value. -3, 0, next comes 5, 8, and then 10, and end with those curly brackets. So again, the domain is the set of all x values. These are all of the x values that occur within this relation. The range is the set of all the y values. So the smallest is -2. We look at all the y values, -2, 0, 4 occurs 1, 2, 3 times, but we only write it once, and then 6, ending with the curly bracket. The domain and range of discrete relations, that word discrete will make more sense once we learn what a continuous relation is, but a discrete relation just means we can list out the ordered pairs. So we're able to list out the domain and range. In this table down here, the domain, I went back to orange, I guess. The domain is the set of all possible x values, again, from least to greatest, -10, -4. 25 occurs twice, but we're just going to write it once. And then the range is the possible y, 1, 3, 52, and 100. Not parentheses. Not parentheses. Parentheses we use for ordered pairs. So we're doing our best with these curly brackets. Oh man. The nicest representation to write the domain and range from is a mapping, because it's already written from least to greatest, -4, 1, and 7, and each x and y value is only listed once. So we can just directly write down the values in the left portion of the mapping. That gives me the domain. That's the x right here. The right portion is the range. -3 and 5. Really the only somewhat challenging representation to find the domain and range from is a graph. You can always kind of make that easier by just writing this as the equivalent representation of a set of ordered pairs, and we'll do that in a second. And once you have a set of ordered pairs, then you can just list off the x and list off the y. We're going to try to do it in a different way that will help us when we are finding the domain and range of continuous relations. So we're going to try this way. So we're going to start with the smallest possible x values on the x-axis on the left of the graph, and we're going to move from left to right, so getting bigger. And we're going to identify as we go which x values have a coordinate or a ordered pair, a point on the graph, and therefore an x coordinate of that value. So there is no point when x is -5. When x is -4, there is. This point has an x coordinate of -4. So that is in the domain. There is a point with an x value of -4. Oh, that's a -6. So small. -6. There is not a point when x is -5. There is a point when x is -4. So I saw the future, I guess. -3, no point there. -2, no point. -1, nope. 0, nope. 1, yes. So when x is 1, there is a point. This point has an x coordinate of 1. Continuing going, and there's 2. 3, no. 4, no. 5, yep. There's a point when x is 5. That means 5 is in the domain. 5 is a possible x value. Looking at the other way we could have done this, let's go ahead and write out this graph, this relation as ordered pairs. So we have -6 and 3, -4 and -4, 1 and -2, 2 and 0, and 5 and 6. So once we write down the relation as just a list of ordered pairs, we can then just look at the x values and translate that up here in the domain. So -6, -4, 1, 2, and 5, and then I could just write it here. I could just write down the range from these ordered pairs, but I'm going to try my other strategy first. So when we're looking at the range, we want to start at the bottom of the graph. Those are the smallest y values, and move up. So there's no point when y is -6, -5. Yes, when y is -4, there is a point. That means -4 is in the range. This point has a y coordinate of -4. -3, no. -2, yes. This point has a y coordinate of -2. -1, nope. 0, yes. No point when y is 1, y is 2, y is 3, yes. There is a point when y is 3. 4, 5, and 6 is my last value in my range. So the possible y values on this graph of this relation are -4, -2, 0, 3, and 6. So let's check that. -4, -2, 0, 3, and 6. So you can just go ahead and write down the ordered pairs and find the domain and range. But the strategy of identifying just directly from the graph the possible x and y will help you out when we move into continuous relations.